So this video is for period 6 because you guys didn't get to these 2 examples in class, so I wanted to go over these with you. And what we are going to do is we are going to factor this quadratic here, x to the power of 4 minus 13x squared plus 36. Now there's 2 ways to factor a quadratic this way, of this kind. We're going to start by thinking of it in our normal, special, magic, happy riddle way. Okay? Let's just look at our lasts. If this were factorable, our 2 numbers are going to have to multiply together to 36. 36 is a constant term. That means we are only going to have numbers at the end. Okay, right? Presumably, you've already looked and seen that there isn't a GCF. There's no common number factor and there's no common letter factor. Okay, so we've got to have numbers here. Now, because we've got a minus there, we've got to have 2 negative numbers there. So play the special magic happy riddle game and you need to think about what numbers multiply to 36 and add to negative 13. Maybe you've figured out that it's minus 9 and minus 4. Oh, if this is going to work, this is what it's got to be. Okay, well now let's look at our center terms, our results of the O, outer, and inner. We've got numbers times x squared. Now, first of all, what multiplies together to make x to the power of 4? X squared times x squared. And second, what multiplies together to get a number times x squared? A number times x squared. So basically, what we've done here is exactly like our simple FOIL factoring, except that because the first term of each factor is an x squared, we get a slightly different pattern. Instead of getting ax squared plus bx plus c, we're basically dealing with ax to the power of 4 plus bx squared plus c, which is the exact same pattern where you're going to have an x squared plus a something times an x squared plus a something, or in our case, minus a something. We're not done. We're going to check it and then we're going to finish, because you should by now be noticing that these are not fully factored, but let's first check. First, x squared times x squared is x to the power of 4. Outers, negative 4 times x squared is minus 4x squared. Inners, negative 9 times x squared is negative 9x squared. And last, 9 times 4 is positive 36, since they're both negative. We combine our like terms. And OMG, this works great, except we're not fully done, because these are both differences of squares. So one of the things we have to notice when we are doing multi-step factoring is that we've got to go one step further. We've got to do x plus 3, x minus 3. We've got to do x plus 2, x minus 2. And so this is our final answer. That's that expression in fully factored form. Amazing. So now I'm going to give you another example, and this time I'd like you to try it yourself. Pause the video. Okay. If it doesn't have that pattern, x to the power of 4, x to the power of 2, constant term, it's not going to work the way we just did it. Pause the video until you've got this. Okay, you're back, and I bet you wrote... Now, I like these ones because they allow us to factor 2 differences of squares. But you're going to see these with all kinds of simple FOIL factors that can be factored as much as we want. So, for example, one last example. Right, so that looks very similar to something we've seen before, where we would say x squared plus 4 and x squared plus 3. 4 times 3 is 12. 4x squared plus 3x squared is 7x squared. But this would be done, right? It would be fully factored. So it's not really a multi-step, it's just a one-step. Okay, hopefully that will help you with a few of the homework problems. Have a great day, and I'll see you guys in class tomorrow.